Okay, so today we're going to cover section 2. It's inductive reasoning. So let's see what inductive reasoning is. So inductive reasoning is a process that includes looking for patterns and making conjectures. And a conjecture is an unproven statement that's based on an observation. So for example, inductive reasoning is, let's say, every time I don't know, drop a ball off the roof, it always will fall to the ground. And if you keep repeatedly dropping something off a roof, it's always going to fall to the ground. So you're going to look at something, you're going to observe something, and then you can make your conjecture. Same thing if you had a pattern of numbers, and you would look for what happened in the past with the pattern, and then from there you can come up with a statement. So for example, if I have the numbers 2, 4, 6, and 8, this is a pattern, and then I would look to see what happened at the beginning of the pattern and see if I can figure out what my next number would be. And it looks like it's adding 2. So this is when you're asked to complete a pattern. This reasoning is inductive reasoning. Next, we have an example here. And it says, describe how to sketch the fourth figure in the pattern. Then sketch the fourth figure. So, obviously, my fourth figure is going to be a circle. And if you notice, the first figure has 2 sections, and 1 is shaded. And then figure 2, it's got 4. And then now in figure 3, it's got 6. How many different separations or sections you think will be in my figure number 4?
8.
Good. So it looks like what they did was they took the figure number, times it by 2. So now we have 8 sections. So I can go ahead and divide this up. And I've got 8 sections, and then I need to color in one of the sections. And notice they're all seem to be up above that halfway point. So we're dividing it into twice as many sections as the figure name. So this is using inductive reasoning, where we look at the pattern of what happened in the past to make our future pattern. Everybody good on that one? Let's move on to example 2. Next one.
I'm still writing.
Okay. We're still using inductive reasoning. So here it wants us to describe the pattern in the numbers 5.01, 5.03, 5.05, 5.07. It wants to know what the next 3 numbers in the pattern will be. So first we have to go back and look. What happened when I went from 5.01 to 5.03 and then the same? What happened each time? And you can see that it looks like that they're adding 0.02 each time. So now to get the next number in the pattern, I'm going to take my 5.07 and add 0.02. 5.09, add another 2 hundredths, so 5.11, and then 5.13. So when you're asked to complete a pattern or a series of numbers, when you look at the pattern that happened in the past, you're using inductive reasoning. Here it says the numbers such as 3, 4, and 5, these are called consecutive integers. It wants us to make and test a conjecture about the sum of any 3 consecutive integers. So here's what I would start doing. So when it wants you to make a conjecture, remember this is going to be a statement. And this statement is going to be true about what's happened when we test this out. So for example, if I take these numbers, 3, 4, and 5, and if I add them, I get 12. Now, in order to come up with some kind of statement, I have to do just more than one example. So let me pick 3 more consecutive integers. Let's say I pick 1, 2, 3. Again, consecutive numbers are in order. So then if I add those, I'm going to get 6. And now I got to look, is there some kind of pattern happening here? Let's pick another series with bigger numbers. Let's say we pick 100, 101, 102. Let's add those because it wants the sum, and I get 303. Now I'm going to go back and see if I can figure out some kind of statement that I can relate the sum to these series of consecutive integers. So a conjecture that I could make, if you notice, it looks like they're taking the second number in your pattern of numbers or your consecutive integers, like the 101, and it looks like they're multiplying it by 3, and that will give me the sum. Let's try it over here with this one. 4 times 3, and it gives me 12. If I take the 2 and times it by 3, and it gives me 6. So my conjecture, I could state that the sum of any 3 consecutive integers, I'm going to change this, integers, is 3 times the second number. That is my statement or my conjecture about the pattern that I've seen with the sum of the 3 consecutive integers and how it will equal the second number times 3. What a counterexample is. So a counterexample is going to be something that would show that a conjecture is false. All you need to do is provide one example for which the conjecture is false. So, and when we can come up with that one example, it's called a counterexample. So, an if-then statement is false if you can find an example for which the hypothesis is true and the conclusion is false. And again, that example is called a counterexample. So let's take my if-then statement here at the bottom. If you live in Florida, then you live in Miami. So here, let's say my hypothesis is true. I live in Florida, but could this statement be proven false? Do I have to live in Miami when I live in Florida? What would be a counterexample?
You can live in Homestead.
Okay, you could live in Homestead. I could live in, where else?
Tampa.
Tampa. Any city in Florida, right? Anybody have another example?
Jacksonville.
Jacksonville, Pembroke Pines, good. Cooper City. I'm sorry?
Orlando.
Yes, good. Okay, so that would be a counterexample for this conditional or this if-then statement would be you live in any of those cities. Any city other than Miami. Any city in Florida. So when you're given an if-then statement, you're not trying to prove something true. If they ask you to prove it false, all you need to find is one example, and then it becomes false. Let's try the next one. Here, it says, find a counterexample. A student makes the following conjecture about the sum of 2 numbers. It says to find a counterexample to disprove the student's conjecture. So here is the student's conjecture. The student is stating that the sum of two numbers is always more than the greater number. Can someone give me a counterexample?
-4 plus 2 equals -2.
Good. So notice the sum, this should be greater than the bigger number, and you can see that it's not. So really what we're doing is we're looking for a negative number to be in the problem. So this is my counter example. Again, I'm not asking you to tell me that 2 plus 3 is 5 and prove this true. I'm looking for something to make it false. I'm not trying to make it true. When I ask you for a counterexample, I'm looking for something to prove it false. Next, we're going to talk about deductive reasoning. And deductive reasoning is going to use facts, definitions, accepted properties, and the laws of logic to form a logical argument. So facts, these are things that we know are true. And we can also, so we'll be using accepted properties, laws of logic, definitions, facts. This is deductive reasoning. We're going to be learning 2 laws of logic, and they're going to be on the next 2 slides. So 2 laws of logic. Our law that we're going to cover is called the law of detachment. What the law of detachment is if the hypothesis of a true conditional statement is true, then the conclusion is also true. So again, remember your P here. This is your hypothesis, and the Q represents your conclusion. So if it's Friday, then I eat pizza. So then they're telling you that the order it goes in is the arrow. So then here they're telling you today is Friday. So then you can automatically conclude that you will eat pizza. So if the hypothesis is true, then you know that the conclusion is also true. And we're going to be practicing these laws. Next law is the law of syllogism. And this is used when the conclusion of one statement is the hypothesis of the other statement. It's sort of like transitive. So notice here, if we have our first if-then statement, if hypothesis P, then conclusion Q, if these two say the same thing, then they sort of cancel out, and then you go from just the red to the green. And we're going to see how this works. So what we're going to see is this conclusion is going to overlap the hypothesis. They're going to say exactly the same thing. And it'll be a little bit clearer when we see the next slide. The slide has an example of the law of syllogism. So we're going to be given 2 conditional statements, and then they want us to take those 2, blend them together to make a new conditional. So my first statement is here, and it says, if it's Friday, then I go to the movies. So notice this conclusion says the exact same thing in the hypothesis of this one. So these are going to like blend together and overlap. So then your final statement is just going to be the original hypothesis and the second conclusion. So these like cancel out. So if it's Friday, then I go to the movies. And then the second statement, if I go to the movies, then I eat popcorn. So here the conclusion would be, if it's Friday, then I eat popcorn. So going to the movies cancels it out. It blends together. Next is an example of the law of detachment. So here it says, if 90 degrees is less than the measure of angle R, which is less than 180, then angle R is obtuse. So now the next statement they're telling us, the measure of R is 155. So then now what conclusion or statement can you make? Then you can go back and say that angle R is obtuse. Everybody good? All right, let's try another example. We're going to use the law of syllogism now. So the next one, if Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she will drive to school. So notice this conclusion of the first statement, she can afford a car, and then it's going to overlap with the hypothesis of this one. So this gets canceled out, and then you're going to write your new statement, and you will say that if Janelle, so you're going to write this, gets a job, and then you'll write, she will drive to school. So you take away the conclusion of the first conditional and the hypothesis of the second conditional and just leave the beginning and the end. So that overlap cancels out. Let's try the next one. The next one says, state the law. So now they're not telling us which one to use. So we have to look at what's given to us and decide, is it the law of syllogism or the law of detachment? So here, if you get an A on your math test, then you can go to the movies. Then the next statement, if you go to the movies, then you can watch your favorite actor. So they're taking these two sentences, and this is what they concluded. And which law is this?
Syllogism.
Good. Law of syllogism. Because notice what they did was they blended it together, and then they took out this part, the conclusion of the first one and the hypothesis of the second one. The next one, state the law. So again, it's either going to be detachment or syllogism. So if x is greater than 12, then x plus 9 is greater than 20. So here it says the value of x is 14. Then what they're concluding is that x plus 9 is greater than 20. So here, this was the conclusion of the first. So because it's true, and 14 is greater than 12, this is the law of detachment. Next slide, we're going to decide, are they using inductive or deductive reasoning to answer the question? So next it says, decide whether inductive or deductive reasoning is used to reach the conclusion and explain your reasoning. So remember, inductive reasoning, this is using or looking at a pattern of something that happened in the past. Deductive is based on the facts or on definitions or properties. So let's look at example A. So here it says, each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to the ground. Did she decide? I'm sorry? Which reasoning? Inductive or? So this will be inductive reasoning. And it's based on a pattern of what she saw when she kicked the ball in the air. Pretty good? Let's try the next one. All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. So this is based on facts about birds and reptiles. So this would be deductive reasoning, because it's based on a fact of what we know about reptiles and birds or parrots.